Before we get into chapter 9 and the first practice problem, I'd like to recap confidence intervals because what we see here with hypothesis testing starting in chapter 9 is really building on that same idea. So, to recap confidence intervals in just a couple of minutes, there were really three versions that we were looking at, right? So, the first version, when we were introduced, meant in the problem we were given the sample mean and the population standard deviation. You might call those x bar and sigma. So when we computed the margin of error, we took the z-score, that's the upper z-score, the upper critical value as it's defined, or you might say z sub alpha over 2. We found that upper z-score that matches with the confidence level. So if it was 95% confidence level, we know that z is 1.96. That's a common one. Maybe the confidence level is 90% or 99% or 80%. We would find the confidence level of the upper critical number, so that the z-score. Okay, so we would take that, we would multiply it by sigma over the square root of our sample size n. That gave us the distance that we would count off of the sample average, which is x bar at the middle. So to calculate the confidence interval, we would say the sample mean x bar minus the margin of error, and the upper value of our confidence interval is the sample mean x bar plus the margin of error. Okay, so just really quick recap of how we do those when we're given the sample mean and the population standard deviation. But then we learned if you have a smaller sample size, typically, or just depending on the case, you're often not given the population standard deviation. Sometimes you're given the sample standard deviation. So if you have a sample average and a sample standard deviation, you might call those x bar and s, then you have to use the upper t-score for your confidence level. So the margin of error formula changes a little bit. It's no longer a z-score, but a t, and it's no longer a sigma, but now it's an s, but still divided by the square root of the sample size. Once you have that margin of error, well, you can subtract and add that number with your sample mean to get your confidence interval where it starts and where it stops. Okay. And finally, the last one, which is very different from the other two. What if you're given a sample proportion of success? So you're not given an average. There's no average sample mean in this case, and there's no standard deviation of any kind. You're given a sample proportion, how many successes out of the total, right? Okay, so we call that sample proportion p hat, and we find the margin of error as the upper z-score for your confidence interval. Maybe it's 95% or 90 or whatever, that z-score. You can get that, all of those in your StatCrunch calculators, these numbers here, right? And then we'll do p hat times q hat divided by n, the square root of that whole thing, will give you the margin of error. And then to get your confidence interval, again, we don't have an average here anymore. We have the p hat. So we take our p hat and we subtract and add that margin of error to get the confidence interval. Okay, so when we go into chapter 9, we're going to see the same three cases again. We're going to see mean, population standard deviation, sample mean, sample standard deviation, sample proportion of success. Okay, so be ready for that. At this point, I'm going to continue with the video, but I invite you, if you haven't already, go ahead and pause and read the beginning of chapter 9 lecture. Read through that, the example, and the definitions of the null and alternative hypotheses. So if you haven't done that already, I'll give you a moment, pause, Okay, we're going to get into practice problem number 1. We are just going to practice developing the null and alternative hypotheses. So let me just read those definitions one more time. The null hypothesis is the position that there is no significant difference between a specific value and the larger population parameter. Okay, so what does that mean? Null, you might know, comes from the word nothing. It has the same root word, null and nothing. So we assume there is no difference uh, in the circumstances, right? So the specific number we're looking at, the specific group of people, sample we're looking at, there's no difference between them and the larger population. So you may have read that example about the Carl's Jr. managers. And that's actually going to be our first example, is to get the null and alternative hypotheses for those that Carl's Jr. manager situation. Okay, the alternative hypothesis, the position that there is a significant difference. Okay, so it's the opposite of the null. And so what does that mean in a problem? Okay, so let's check it out. State the null and alternative hypotheses, and let me reread that Carl's Jr. example here in part A. A manager at Carl's Jr. wishes to know if the average salary of managers in the company is more than the national average of all fast food restaurant managers. Okay, so they're wondering, hey, do Carl's Jr. managers get paid more on average than compared to all other fast food restaurant managers on average? Okay. Then we get some numbers. The national average is $42,000 per year. And so they're referring to all fast food restaurant managers. The national average for all the fast food restaurants, $42,000 per year. But a random sample of 30 Carl's Jr. managers has a mean of 43,260. Say, oh, wow, seems like Carl's Jr. managers are making a little bit more, a little over 1,000 more. Not a lot, but they're making a little bit more. And that's based on a sample of 30 managers. I mean, then we think of 30 as the cutoff for, a good sample size, right? So this would be fun if we were in class, because I would say, hey, you guys, just based on your intuition, does that seem like enough evidence that Carl's Jr. managers really do make more than all fast food restaurant managers together in the country? And usually when I ask that to a class, I get a mix. Some people are like, yeah, I mean, they're making 30 people and the average is 43,000, over 43,000. And other people are more skeptical. They're like, I mean, I know you sampled 30, but maybe those 30 Carl's Jr. managers that you sampled, maybe they just happen to make more. But really, if you looked at all the Carl's Jr. managers, right, thousands of them, actually, it would balance out, and it might be pretty much 42,000. Maybe you looked at an area like in San Diego. People typically make more money in San Diego because the cost of living's higher and such. Anyway, we will actually look into it and answer that question of, is this enough evidence, a little bit later. Right now, we're just trying to start at level 1, state the null and alternative hypotheses. Okay, so what is the null hypothesis here? I haven't pulled the page down because all we have is an answer to this one. So remember, the null hypothesis, there is no difference. We assume there's no difference between Carl's Jr. managers and any other managers. Okay, so here it is. The null hypothesis, which we call H sub 0, 0 like nothing, right? Nada. H0, the average Carl's Jr. manager's salary is equal to $42,000. There's no difference between Carl's Jr. managers and any other fast food managers. Okay. Well, then what is the alternative? This is going to vary a little bit problem to problem. The way it's stated here, right, we think of it as the opposite of the null, but the way this one's stated, let's see the average. Okay, so what's happening? So we're going to assume it's not equal to 42,000. So I had to read that one more time. We're going to assume the average Carl's Jr. manager's salary is more than 42,000. Okay. So if it's not equal to, then the alternative is that they're making more. All right. Again, this is going to vary problem to problem. We say more than here because they're making more. In other cases, it might be less than. In other cases, it might simply just be not equal. Okay. So there's the null and alternative. These are the null and alternative hypotheses written out in words. What you can do, we can write it out like a sentence. Typically, though, we really don't want to write these out as a sentence. We've got a better notation for that. Notice we're talking about averages. Averages, right? Well, we're going to think of the average like mu. So we're thinking of all the Carl's Jr. managers as the entire population. Okay. So if you look at all Carl's Jr. managers, actually, if you looked at all of them, the average would be 42,000. Okay. And the alternative is that, no, actually, if you look at all Carl's Jr. managers, it would be more than 42,000. And that would match the language here, just in much simpler terms. Okay, we like that. Okay, we will look deeper into this problem in the next video. Let's go on to part B. And I don't want to reveal anything yet. Let me read this one just to state the null and alternative hypotheses. A psychologist feels that playing soft music for students during a test will change the results of the test. The psychologist is not sure whether the grades will be higher or lower if they play the music. Okay. Unlike the last example where they said that manager, was wondering if Carl's Jr. managers made more than, we specifically saw the phrase more than in the question. But here, the psychologist is not sure whether the grades will be higher or lower. Over the past several semesters, the mean test score has been 73. Okay. So let's think. The null hypothesis. Null meaning no change, nothing. So we're going to assume that if this teacher plays music, there's no change. That doesn't impact the students at all. So that would mean that the test average with music is not going to be any different than the test score without music. So it will still equal 73. Okay. And we're going to assume that this teacher is going to play music over many, many semesters. So we're looking at a lot of students. And, in the end, there's not going to be any effect when you think of, hundreds of students maybe. Okay. What's the alternative here? And you notice the language. The psychologist is not sure whether the grades will be higher or lower. So she's not, or he or she is not speculating the grades go up or go down. They're just saying, we have no idea. So all we can say is simply that the test average with music will not equal 73. We don't know if it goes up or maybe it goes down. Simply that it won't be 73. And we know that again because right there in the statement, they're not sure whether it will be higher or lower. Now we might set this up a little bit different with just symbols. So we might say much simpler, the null hypothesis, the average for the students is going to be equal to 73. The alternative here, that the average of all this teacher's students will not equal 73. Maybe higher, maybe lower. We don't know. Whatever it is, it just won't equal 73. Okay. So that does it for practice problem number 1. I have one last statement there at the bottom of page 1. So it says the null hypothesis is always assumed to be true. It takes very convincing evidence for the alternative hypothesis to win, if you will. Let me go back. I'd like to elaborate that on a little bit. A big part of hypothesis testing is the logic that's involved. So let me try and tie it to something maybe we're more familiar with. So imagine a courtroom, right? So if a defendant goes into a trial, you may have heard the phrase, there has to be, reasonable doubt that this person did it. So we assume that they are innocent, right? We need a lot of evidence that they are guilty to convict them, right? So in the United States, someone is innocent until proven guilty. We assume you're innocent. So if there's maybe a little bit of evidence against you, that what that means is that that might not be enough. We might still decide that you are not guilty, even if there is a little bit of evidence, pointing to that you did the crime. Jurors are only going to say that you are guilty if there's a lot of evidence, if it goes beyond a reasonable doubt. So it's the same thing here. If you think back to that Carl's Jr. manager example, right? Those 30 managers averaged more than 42,000. But the question is that enough evidence? So sure, 30 of them, they averaged a little bit more, but did they earn enough more that we can say it looks like Carl's Jr. really is paying people more than other fast food managers, right? Like one way to describe this would be to say, is it evidence? Is it enough evidence? Is it bigger than enough? Right. Okay. So I like the analogy of the innocent until proven guilty. We're going to look much deeper into that when we get into the next two practice problems, number 2 and number 3. Go ahead and read the part about the hypothesis test and some of those definitions, and we're going to walk through all 5 steps in practice problem 2 and 3 next video. See you there.